For reference purposes, here's the graph of y equals log base 2 of x. When we transform the graph of a logarithmic function, we know this is going to be the general shape. I'm going to have an asymptote on one side, and I'm going to go up or down slowly to the other side. When we make these transformations, we want to make sure we keep track of two things. We want to make sure we keep track of where does that point 1, 0 go as a result of the transformations, and we want to keep track of the vertical asymptote. Where does that end up? So, for example, if I want to sketch a graph of log base 2 of x minus 2, I know that this minus 2 is going to move the whole thing 2 to the right of where it started. So my point that used to be at 1, 0, if I move it 2 to the right, that's an x transformation, so it's going to affect the x coordinate. 2 to the right, now it's going to be, instead of 1, 0, it's going to be at 3, 0. And if you want to do that ahead of time and then notice where it's going to end up and then graph it, that's fine. And if you want to go, okay, here's the point 1, 0, I'm going to move it 2 to the right, there it is. What's that point? It's 3, 0. It doesn't matter which order you think of it in. Either way, it's going to end up right there. If I take a vertical asymptote and move it left or right, I'm going to notice. If I take a vertical asymptote and move it up or down, it was a vertical line. It's still a vertical line, hasn't changed. But if I move it left or right, then I can tell. Started out as the y-axis, x equals 0, and the whole thing's going to move 2 to the right. So now it's going to be at x equals 2. There's my vertical asymptote, x equals 2. Those are the only two transformations that happened here, or actually that's only one transformation. That's the only transformation that happened. The whole thing moved 2 to the right. The shape is the same. I'm going to go up slowly to the right, vertical asymptote to the left, and there's my new graph. Something else we see with logarithmic graphs sometimes is reflections. If I have a negative out in front here, that's a vertical reflection. Everything that used to be down goes up. Everything that used to be up goes down. If I reflect my vertical asymptote, used to be x equals 0. If I flip it over, it's still x equals 0 if I flip it vertically. So it doesn't move. My point, 1, 0. Well, everything above the x-axis moves down when I reflect. Everything below the x-axis moves up if I reflect vertically. The point 1, 0 is on the x-axis. So if I reflect it over the x-axis, nothing happens. Since it's on the line that I'm reflecting over, there it is. What is going to happen is my vertical asymptote, that is usually the negative y-axis, that is going to change. It's going to be the upper part of the y-axis. That's the vertical asymptote. So I'm going to go up this way by the vertical asymptote, and instead of going up slowly to the right, I'm going to go down slowly to the right. And there's my transformed graph, negative log base 2 of x. What if I reflect the other way, log base 2 of negative x? So this is a left to right reflection. My point, that's usually at 1, 0, is going to reflect across the y-axis so that it's the same distance away on the other side of the y-axis. Used to be here. Now it's reflected across at negative 1, 0. My vertical asymptote, x equals 0, the y-axis. If I reflect left to right, if I'm reflecting over the y-axis doesn't change. So my vertical asymptote is still x equals 0, I'm just going to be coming towards it from the other direction. Instead of coming towards it from the right, I'm going to be coming towards it from the left. And instead of going up slowly to the right, I will go up slowly to the left. Shape of a logarithmic function, and there's my graph. And then we have the everything but the kitchen sink example, where we put several of these transformations into one function. So let's take a look at what's happening here. In the order we want to do them in, I'm going to notice the plus 1. That's a shift 1 to the left. The x's four little things are backwards. You would think plus 1 would go to the right, but it goes to the left. So 1 to the left. My point, I'm going to follow the progress of my point and my vertical asymptote. So my point 1, 0 is going to move 1 to the left. If I move it 1 to the left, it affects the x coordinate, so now it's at 0, 0. My vertical asymptote used to be x equals 0. I'm going to move the whole thing 1 to the left, and that is a transformation you can notice. If I move it 1 to the left, now it's at x equals -1. In the order that we're going to do them, the next thing we take care of is reflections and stretches or shrinks. There are no stretches or shrinks, but reflections there is. I'm going to reflect. And that's a vertical reflection, top to bottom, up to down, since it's on the outside of the function. So everything up goes down, everything down goes up. My point is on the x-axis, not above it, not below it. So my point 0, 0 is unaffected by the vertical reflection. My vertical asymptote, x equals -1, a vertical line, if I reflect it vertically, that's not going to do anything to it. Doesn't change. So I just have to remember when I draw it that I'm going up along the asymptote instead of down. And finally, might be the first thing you notice, but it's the last thing we do, the +3 on the outside of the function that's added. That's a vertical shift up by 3. So my point that right now is at 0, 0, I'm going to move it up 3. That's going to affect the y coordinate, but not the x coordinate. X is still 0, but now y is 3, and that's the final home of that point, y equals 3. If I take a vertical line and shift it up, I'm not really going to be able to notice a difference. So my vertical asymptote is not affected by a shift upward. Vertical asymptote x equals -1. Now we're ready to put in the graph. I had a reflection, so instead of the negative part of this line being the asymptote, it's going to be the positive part, vertical asymptote going up. And instead of going up slowly to the right, I'm going to go down slowly to the right. And there's my graph.